It is March 12th. Is it clear? It is clear up there. No, it's not. It's March 13th, 2025. Today is our last day talking about particle motion. We've been dealing with this stuff all year. There are 3 final little things we're going to add to our list of rules for particle motion. I have very, very short notes, and then one example we're going to spend the rest of class working on that will throw as many different particle motion things into one problem. As we go through beyond those first 3 new things, it might be helpful to take out that review packet that I gave you with all sorts of things. There's a whole page in there about particle motion. If you feel like you don't remember the rules about speeding up, slowing down, moving left, moving right, you may want to have that out in front of you. There are 3 new things we have to deal with today. First thing, if I do a definite integral of velocity, bless you. If I integrate my velocity from A to B, a what? You're close. V of t is the rate of change of it's the velocity, the rate of change of the distance. You integrate that, you get your, not necessarily distance traveled, but if we use our language from before, there was a small n word, net. Yeah, net change in position. I think I'm just going to call this kind of my change in position. The official term for this is the displacement of something, which we can think about as our change in position. For example, and I'm not using the camera for this part, I'm going to use this stuff over here. I have absolutely no clue why they have these little black marks on the floor in some of the spaces. However, it lets me kind of demonstrate something. Let's call this space 1, 2, 3, so on. I'm at space 3. I'm going to move up here, I'm going to move back here, I'm now at space 4. What was my displacement? 1. I was starting at 3, I'm ending at 4. I don't care, I moved way forward, way back. My change in position is 1 space. That's displacement. Next thing we have to deal with. If I want to find my final position, I can take my starting position I can add my displacement to that, and that's going to give me my ending position or final position. Which should make some sense. Tell me where you're starting. Add your change in position to that. It's going to give you your place you're ending. Going back to that example I just showed you, I was on space 3. My net change in position was 1. I ended up at space 4. Okay. Now, what you were talking about a moment ago, the distance traveled, well, I'm coming back here. I got space 3. I'm moving up 1, 2, 3 spaces, back 1, 2 spaces. I've traveled 1 space total. What was the total distance that I actually moved? Yeah, if you were in a car and looking at the odometer.
6 miles.
I've lost track of what I did. I think 5. I think I was at 3, I went up to 6, went back to 4. I went a total of 5 spaces. Well, to talk about that, aren't we ignoring the direction I'm traveling?
Yes.
Well, the direction when we're dealing with velocity is your sign, your positive or negative. What mathematically says ignore the sign? Absolute value. If I go and integrate from A to B the absolute value of my velocity, That's going to give me the total distance traveled. I don't care what direction I'm moving in. It's all adding on to your distance. If you're at home and you drive to the school and then drive back home, your total distance isn't 0, even though you started and stopped in the same place. Your displacement would be 0, but not the total distance traveled. These are all the new things we're getting in our notes for today. I have one example we're going to take a look at, and that's what I have to say about that. Let me pass some stuff out. I will also admit to you, I am very, very proud of this example I came up with, because I managed to cram as many possible things into one problem. It is not A through D or A through F. I think it is A through L. Oh, at the end of the year, I think I have one that goes all the way to Z. We're not going to deal with that for right now. Oh, by the way, you also will need your calculators for what we're about to do. So, my goal with this example is just to show you as many different particle motion things as possible. Also, before when we did particle motion, we didn't do a whole lot with the calculator, certainly not the derivative or integral features of the calculator. So I need to show you how we apply those to problems over here. We're also going to make sure we're focusing on language and notation and all that good stuff. You got two particles. Particle P, I'm giving you the velocity. Right over there, we've got a formula. Actually, how about you take a moment, just get that stored in Y1 on the calculator. Q, we just have a table of values for that. Okay, well, we'll deal with that when we get there. Part A, I want to find the acceleration of particle P at time 2.1 seconds. I'm going to start by saying A, but because there are two different particles here, I really do need to distinguish them. I'm going to say A sub P of 2.1. That's what I'm looking for. Now, I have to show a tiny bit of work. What do I have to show? Yes, you have to show you're finding acceleration by taking the derivative of V sub P of 2.1. Now, how do you do the derivative? On the calculator, do your end deriv stuff. Make sure you're right in that line, then go to the calculator. And also, since there were units given in this problem, see if you can figure out your units. Does negative 2.180 sound right? Are you all in radian mode, by the way? Okay. Units. Good. Units for velocity were feet per second. We're dividing by the units of time. So feet per second. We're going to call this feet per second squared. Good. At time 2.1, is the speed increasing or decreasing? Now, if I ask you that, that's really like also asking, are we speeding up or slowing down? It's the same thing. How do I do speeding up, slowing down? What do I need? Say a little more. Yeah, we need velocity and acceleration. Nicely, I already had you do the acceleration parts. So we need to go find our velocity at time 2.1, and then reach a conclusion based on that, and see if you can write up that conclusion. By the way, please don't tell me V sub P of 2.1 equals positive or negative. Actually, give me a number there. And I hope you weren't doing any n deriv or anything, stuff like that. You were just doing y1 parentheses. Don't write that. Write v sub p of 2.1, but then just go evaluate. Negative 1.801, I think, for your velocity. That's feet per second. So what? Speeding up or slowing down? Speeding up. Good. We're going to say that we're speeding up, or I guess we could say that our speed is increasing. Were you able to justify? Because v sub p, make sure, though, you're still including the 2.1. I guess you could say v sub p of t at t equals 2.1, but I think this is the more concise way to do it. And a sub p of 2.1 have the same sign. And I would prefer that over, like, they're both negative, because that's not all it takes for them to be speeding up. They could be speeding up if they're both positive. The fact that they have the same sign is the specific thing that makes it speeding up. Okay, how about you try letter C? Acceleration of particle q at time 2.1. Again, I'm going to start this by saying I'm doing the derivative of my velocity at time 2.1. And I think I was really nice that 2.1 is exactly in between 1.5 and 2.7, but honestly, any number between 1.5 and 2.7 you could find using the exact same calculation. We are not finding the actual acceleration, we're just approximating it. Make sure you're sticking units on this. Particle motion won't always include units, but here, since it does, we've got to in our answers. Can someone tell me something? I'm not sold. Something different? Negative 2.417, I think. Check your typing in.
Yeah.
You found it? Feet per second squared. You can't see that. Negative 2.417 feet per second squared. Okay. Finally, something new. Find the position of particle P at time 5 seconds. Well, to do my position, I'm going to take my initial position and add my displacement, my net change in position to this thing. What is my starting position of particle P? How do you know that? Aha. We have to take that from the initial setup for the problem. So I'm going to say negative 2. To that, I'm going to add my displacement. I'm going to add the integral from 0 to 5 of v sub p of t dt. Go do that on the calculator. And of course, because it's an integral, it may take a little while for the calculator to come up with that. Does that look like your answer? 15.842? Problem?
Yeah, I got 0.
Which is what I got when I did my notes earlier. I know why, because in pre-calc we're dealing with things in degree mode right now. Okay, how about that?
Yeah.
Wonderful. Oh dear. 0.238 will be our position. Okay.
When we say that in feet or
Feet, I guess, would be okay. Since I just told you a starting position is x equals -2, that's sort of just 2 on like a number line, whatever. Whatever. Moving on. Okay, now we're going to approximate the position of particle Q at t equals 5 seconds. We're going to use a trapezoid sum for subintervals that are given in that table. Do you know your starting position of particle Q? That's P. What was that? Not 0. 0 is my starting velocity. 1 is going to be my initial position. So what we're going to do is the exact same idea. We're going to do 1 plus the integral from 0 to 5 of v sub q of t dt. Now, I think to get us started, I'm going to draw out a picture to kind of figure things out, although I feel like the picture is going to break down a little bit when we get into our negative things. But hopefully it'll be enough for us to start our trapezoid idea. Let me see here. I've got a point at 0, 0. I've got a point at 1.5, comma 8.2, 2.7, comma 5.3, 3.5, comma negative 2.4, 5, comma negative 0.7. So, I don't know, something vaguely like that. I'm just guessing here because I've got no clue in between the x values. But my first trapezoid is going to have a base of 1.5. And then I want to do the average of my heights at 0 and 1.5. So actually my first trapezoid is really just a triangle. I think, though, I'm going to write it out as 1.5, my base, times the average of my heights. Maybe I'll skip the v sub q stuff and just go straight to 0 plus 8.2 divided by 2. The next trapezoid, what's your base of the next one? 1.2. 1.2. Average of the heights is 8.2 plus 5.3 divided by 2. I definitely feel like the picture breaks down a little bit after this. You've got a positive height and negative height, but I think your formula is going to work the exact same way. Base times the average of the heights, base times the average of the heights. See if you can finish this calculation. Um, 2.7 to 3.5, that should be 0.8. Average of 5.3 and minus 2.4. 3.5 to 5, that's a base of 1.5. Average of negative 2.4 and negative 0.7. Make sure you're also factoring in that one that was out front. Don't lose that one. And see what you can get. Anyone have something they could share? Go for it.
14.085.
That is what I got. You people too? Make sense? Of course, if I could make you do a trapezoid thing, I could make you do a left endpoint sum, right endpoint sum. If I gave you more information, we could do midpoint sums Guess we could do a midpoint sum. This could be in the midpoint of, well, whatever. Okay. Using the information from parts D and E, at time 5, are the particles moving toward each other or away from each other? Explain your reasoning. How would I approach this? Zia. I'm definitely going to need my velocity. Is there anything else I need, though? Yeah, I need to know where they are and what direction they're moving. Are they then moving towards each other? Are they moving away from me? Then I'm going to be able to tell that. So how about I start by just dealing with the positions, because I already know my positions. I know the position of particle P is 0.238. So particle P is over here, 0.238. That's P. And I know that Q is at 14.085. You need to go get your velocities. So take a moment. Let's find the velocity of particle P at time 5. And we'll also need the velocity of Q at 2.5. Oh my gosh. Let's try that again. How about 5, not 0.5? Maybe 0.293 for particle P. How do you find the velocity of particle Q at time 5? Oh, we're just pulling it straight from the table. Velocity of particle Q at time 5 is negative 0.7. So particle P is moving to the right. Particle Q is moving to the left. I think you can probably see it now. Towards or away from? Towards. Okay, and now I got to write some stuff out. At t equals 5, the particles are moving towards each other. Because we've sort of done things like this before where I talk about are moving towards the origin or away from the origin. We're just going to talk about towards each other, away from each other in terms of position and velocity. So I'm going to say, because the position of particle P is 0.238, and P is moving right, although actually that's not good enough. How do I know P is moving right? V sub P of 5 is positive. V sub P of 5 is positive. And Q is at a position of 14.085 and moving left. Still on the screen. And again, justify that part as well, since V sub Q of 5 is negative. If you had a setup like this and V was moving left and Q was moving right, they'd be moving away from each other. If you have a setup like this and they're both moving to the left, you really can't say, because one could be gaining on the other, one could be moving faster. We need more information because, again, velocity isn't something constant here. Velocity is always changing based on the function you were given. You really wouldn't be able to tell that. I wouldn't ask that. The College Board wouldn't ask that. Okay. Next, find the total distance traveled by particle p over the interval from 0 to 5. This is that new formula that I gave you today that says we're going to integrate the absolute value of our velocity from 0 to 5. My total distance is the integral from 0 to 5 of the absolute value of v sub p of t dt. Now, should I be including my starting position on this? Going back to when I walked, I started at 3. I moved up a little bit, moved back, ended up at 4. Do I care that I started at 3 to get to the whole distance? No, I don't care about that. We're going to go to our calculator to do this. Before we do that, you're not allowed to just integrate and make sure the final answer is positive. Integration doesn't work that way. We got to make sure all the little things we're adding up are positive. So it's a little more involved than that. Do you know how to do absolute value on the calculator? 2 nods or 3 nods? Well, we're still going to see it anyhow. I'm going to go and integrate fn int, sort of showing up there, fn int from 0 to 5. Okay, those of you who nodded, how do I do absolute value on here? Math? Aha. Math, number, and that first option, ABS, is the absolute value. I want to integrate the absolute value of y1. And I want to do this problem dx. It's probably going to take longer than normal to do this. The absolute value just makes the calculation harder for the calculator. So we'll wait a little bit and a little more. 11.437. I guess we probably should put units on this because I was talking about feet per second for velocity and things. How much total distance have we traveled? We've traveled 11.437 feet. Does that make sense? One important thing, though, just to keep in mind is when you add your initial position and when you don't. Here, I'm not factoring that initial position in. I am going to pause this for a moment.